This topic is called classifying the graph of a function. So the problem says, for each function below, choose the correct description of its graph. And we have three different functions there. We have f of x equals 3, h of x equals 3x squared minus 4x, and k of x equals negative 4x minus 3. And so what we want to try and do is, just by looking at the function, just by identifying the function just by the way that it looks in function form, we want to be able to tell what kind of graph that function is going to produce. Alright, so anytime we have something that is in function notation, so if we look at the first one, anytime we have something that says f of x or h of x or k of x, we know that we can think of that as also it being y equals 3. Anytime we have something in function notation, it's just another way of using the variable y. Instead of using variable y, we just use the function notation to show that it is a function using x in our variable as our variable. So we know that the first one is y equals 3. Anytime we have a function that is in the form y equals a number, that means it's just going to be a horizontal line that goes through that number, because this is just saying that no matter what your x value is, your y value is always going to be 3. And so if we were to think of that as a graph, that would be just a horizontal line going through 3 on the y-axis. So we know that the first one would be a horizontal line, so we would select horizontal line for that first one. The second one, h of x equals 3x squared minus 4x. We can think of this as y equals 3x squared minus 4x. Anytime we have function notation, we can replace that function notation with a y. So we have this function y equals 3x squared minus 4x. Anytime we have a term that is to the second power, we know that that's going to be a quadratic function. Anytime we have a quadratic function, we know that that graph of that quadratic function is going to be a parabola. And so we have two options for parabolas. We have parabolas opening down and parabolas opening up. Now the way to tell if a quadratic function opens up or down, we want to look at our leading coefficient. So we want to look at the number in front of our x squared term. And so in this case, this is a 3. Anytime that you have a positive number, your parabola is going to open up. So it's going to look more like a U. It's going to be a U-shaped graph. If this were negative, it would open downward. So that means that it would look more like an arch, like the arch you would see in St. Louis. So looking at this one, we know that our first term here has a positive 3. So we know that that second function is going to be a parabola opening upwards. So it's going to look more like a U-shaped graph instead of opening down like an arch. So then the last one we have is k of x equals negative 4x minus 3. So just like the other ones, we can think of this in the form y equals negative 4x minus 3. So looking at this, our highest degree for our term is just an x. So anytime we just have an x as our highest, we know that that's going to be a line. And so we have multiple options. We have vertical line, we have horizontal line, we have a line with a negative slope, we have a line with a positive slope. So we can automatically eliminate vertical line and horizontal line because this linear function actually has an x term. Vertical and horizontal lines are just a y equals or an x equals with only one variable in it. And so this has an x and a y, so we know that this is going to be either a line with a negative slope or a line with a positive slope. And so since we know that slope-intercept form of a line is y equals mx plus b, we know that that first number in front of the x is going to tell us our slope of our line. So the m is our slope. And so looking at this m, we know that the slope is negative, so we know that the last function that we have there is a line with a negative slope, so we would select that as our last choice. I hope this helps with this topic, and good luck.